right, the time now is 7:30. Let's get ready. Woohoo! All right, so children, just to let you know, all right, all right, today we are going to do a very crazy question. All right, we're going to do a very crazy question. Last week, I gave you this question already. Oh, last week, I gave you this question. Okay, and it's related to the topic that we are doing. All these like similar volume, similar area, this type of question. Oh, I will show you how the question can be asked. All right, it will be challenging. Okay, but you all need to adapt to it lah. All right, so one of the students actually asked me this question. All right, so I'm just showing you. All right, other schools are asking. You better get ready lah. Huh? All right, so this is the question that last week I threw at you. This is the question which I last week threw at you. All right, if you can still remember. Okay. Ready? Okay, All right, so down here, it says that a closed inverted conical container. This is a closed inverted conical container with radius 12 and height 30, contains water to a depth of 20. Using similar triangle, find the height h of the water now. All right. So you're looking for h now. Can you see now? After you invert it. Wow, Joe, why can't this type of question? Yeah, precisely, man. All right. So this type of question is not easy to handle. All right. So I need you to know certain things first. Number one, all right, something called the volume of cone. All right, volume of cone. If you can still recall, the volume of cone is given as 1/3 pi r squared h. Okay, that is the volume of cone, 1/3 pi r squared h. Can? Okay, that's the formula for volume of cone, 1/3 pi r squared h. So these two containers are exactly the same. They are exactly the same. The first situation is it is kind of standing on a tip. All right. So the first situation is you are having the cone in this format. Okay. And the question, right, actually give you a clue. The question say, right, you can actually use something called similar triangle to assist you. Right, I don't know how many of you try this question. Right, I don't know how many of you try this question. Okay, but this is how we are going to look at the question. Right, let's take a look at this question together. Okay, this is quite difficult. All right, this is quite difficult. Right, if you can understand, then it'll be very good for you, children. Can? So this is the center, and down here, right, they say use similar triangle, right? So I'm going to use something called similar triangle to assist me lah. Can you see the triangle down here, children? Can you see? All right, so for those who are lost, right, this particular question is what I gave you last week as an extra question. All right, what I gave you as an extra question last week. Okay, it's related to what we are learning right now. All right, things like area, volumes, ratio. Remember that? Okay. All right, so children, down here, the question gives us the height down here as 30. The height 30, right, is the entire container. Right, it's the entire cone, the height of the cone. And down here is the depth of the water, the height of the water, which is 20. And after that, we turn it upside down. After we turn it upside down like this, all right, we are supposed to find what's the h. Obviously, the h should be different from all this, all right, because the bottom is much more broader. Broader means what? It occupies, how to say, it can fill up with more water, right? So once it fill up with more water, what happen? The height will be shorter. Can you imagine or not? Can or not? Okay, so down here, right, with this information, right, and I can see a similar triangle involved here. All right, I can see the similar triangle involved here. It's actually the big triangle like this. All right, the big triangle like this versus the small triangle like this. All right, so I purposely draw out, right, so that you all can see a little bit more clearer. Okay, the 90 is here. They are similar triangle. Down here is 12 cm. Down here is 20. And down here is 30 cm. Okay, the only thing that I don't know is this portion here. Right, which is like the radius of the water. All right, are you still following me? You're still here, right? Hello? All right, you're still here, right? Okay, good. All right, so I'm just looking for this portion here. I call this XCM, can? Okay, so if you use something called similar triangle, you compare small versus big. Right, similar triangle, you compare small versus big. You compare X versus 12 is equal to what? 20 versus 30. Hello, Ali. All right, you compare small versus big, small versus big. Single fraction equal to single fraction, what you do? You do a cross multiplication. This times this times this. X times 30 is 30x. 12 times 20 is 240. X will be equal to 240 over 30. All right, for those who just come in, all right, this was the question I gave you all last week as an extra question homework. All right, I want to show you that some questions like this, it might appear, all right, in your test or whatever. Just get ready for it. Can? Right. Okay, moving on, moving forward. Children, come, continue. So I use similar triangle, right, to find my radius of the small portion, which is this portion here. All right, this portion is 8 already. Just to let you know, right, this portion is filled with what? This portion is filled with water, right? This portion, the bottom part, right, is filled with water. All right, so this portion is filled with water here. Can I go and find the volume of this water here? So volume of water in cone is what? All right, I gave you the formula already. The formula is at the corner here, 1/3 pi r square h. All right, 1/3 pi r square h. So it's 1/3 times pi. The question never say pi is what. All right, but we just keep it as a pi first. Right, we don't know what is pi. And to try to reduce the decimals and all this, I keep it as a pi. R squared, what's the R? R squared is in this case, is the 8 square. Can you see that? And the height of the water, the depth of the water is 20. Can you see that? So I'm just finding the amount of water in the cone. All right, so if I press my calculator, 1/3 times 64 times 20, what do I get? Let me press 1/3 times 64 times 20. That will give you 426 and 2/3. All right, 426 and 2/3. And I put it in terms of pi. So I leave it as pi like that. Can you see now? cm cubed. So this is the amount of water in the cone. Can or not? Can, okay? Which means that if I turn it upside down, right? Which means that if I turn it upside down now, now the cone becomes like that. All right. Now the cone becomes like that. And now the height of the water is like that only. All right. So down here is the water. The water, right? The amount of water here is the same. Can you see not? So I can say that down here, the volume is still the same. Correct or not? It's still 426, right? Because it's the same amount of water inside, what? Correct or not? All right. I hope you can understand up to here. Okay. Okay, then how? Ayah, how? The question asked me to find the height of this one. The question asked me to find the height of this one. This green color height down here. How do I find? So sometimes, right, you got to be a little bit extra. You have to find some other things. Right? You have to be a little bit more extra to find other things like what? Maybe can I kepo a bit to find the empty spaces on top or not? Right? Can I go and find the empty spaces on top or not? Right? Because the on top looks like a triangle, right? Right? And if it's a triangle, right, then we can use similar triangle maybe. Down here is similar to down here, right? Can you see not? Oh, then the entire height of the container is 30 already, what? Right? I just need to find the top portion, the white color portion. Right? The empty space. Can you see not? Maybe? So I go ahead and find the volume of the empty space. Volume of empty space. Okay, so sometimes, right, if you don't know things, right, you just got to take a leap of faith, lah. Just jump in, lah. Go and find something first. All right, just take a leap of faith and jump and do something, right, rather than not doing anything. Hey, hello, why you got sing song one? Oi. Oh my goodness. All right, anyway. All right, so how do you find the volume of empty space? Okay, I need to find the volume of the cone first, the entire cone. Volume of entire cone. Less out the what? Less out the volume of the water, right? Does it make sense? That's the volume of the empty space. Okay, come. So volume of the entire cone, same, 1/3 pi r. What is r? Look at the top. The radius of the big cone is 12. 1/3 pi r squared. H is the 30, the entire height of the cone. Minus away the volume of the water, which is, in terms of pi, very nicely done, 2/3 pi. Can you see or not? Beautiful. So when you find the volume of the empty space, right, don't press your pi. Your pi is part of the answer. Can you see or not? So that you can have a very exact value. So I press your calculator, 1/3 times 12 times 12 times 30. 1440 minus 426 and 2/3. And your pi, just put it at the back. Right, this is 10, 13, and 1/3. Can you still follow? Can? Okay, then how? Okay, so now you got the volume of the empty spaces already. Right, you got the volume of the empty space already. What can I do? What can I do? Yeah. I need to compare lah. I need to compare things. Okay, I need to compare things. Okay, but before that, right, what is the volume of the entire cone? I've forgotten. This one, let me write it out first. 1/3 times 12 times 12 times 30, 1440 pi. Okay, this is the entire cone. Okay, this is the entire cone. Okay, and I'm looking for H. I'm looking for H. The entire cone is actually represented by this whole thing, which is 30, right? This whole thing is 30. Right, given by the question. If I need to compare similar triangle, right, I need to compare the top part versus the whole thing. All right, I need to compare a triangle. I cannot compare the bottom part. So the top portion down here, right, what can I call it in terms of the length? Remember, the black color line is 30. This blue color line, isn't it 30 minus HCM? Can or not? Is that okay? Is that okay? All right, so my height is down there already. My height is down there already. All right, so let me just extract out my drawing for you again. All right, so down here I have this diagram here versus another small triangle here. This is the yellow one, okay? And this portion is called H. And the no, this portion is not called H. This portion is called 30 minus H, sorry. This portion is called 30 minus H.